Hey everybody, thanks for being here. You know, the world of fintech can be a small, sometimes lonely place, and among all the fintech people, being the fintech UI people can be even lonelier. So I'm really glad to have this many people all in one place to talk about iframes. Thanks for being here. Really great embeddable UIs have been a huge part of the success of big fintech players like Stripe, Affirm, and Plaid. But building your first embedded UI is really hard, and operating them at scale can be even harder. In this talk, I'd like to give you some advice and some stories from my years building embeddable UIs. We'll talk about how to think about product design, how to think about API design, and some tips for when you get started for engineering. We'll also have some fun horror stories, like the iframe that showed up blank, and the font that can steal your identity. Let's get started. So why should you listen to my advice? Hello, I'm Adam Solove, and I'm currently the head of product at Rainforest. Previously, I spent 3 years at Stripe as an engineer and engineering manager on the teams building Stripe.js, Elements, Checkout, all of Stripe's embeddable payment UIs. Nowadays, I'm the head of product at Rainforest, which does payments for platforms. And the unique thing about Rainforest is we provide embeddable versions of the entire payments lifecycle, from merchant onboarding, accepting payments, dashboarding, and reporting. I say this not as a sales pitch, but just so you know that leading product at Rainforest is primarily thinking about embeddable components. Now back to the story. What are embedded UIs? Well, in the history of fintech, let's imagine you were trying to buy something online 25 years ago. Payments were not at all integrated with the experience of trying to buy something. So you might go to a niche small merchant's site, see something really cool that you want to buy, and then you would shut your computer and go do some other physical thing, write a check, mail an envelope, in order to place the order. As time went on, we got to the phase of integrated payments, where you're browsing the website with the thing you want to buy, and you put the items you want in your cart, and you say, I want to pay, and the merchant says, congratulations, instead of paying here, we're going to send you to some terrible merchant services gateway, or if you're lucky, maybe PayPal, to go make the payment. And the current generation of payments companies that are successful basically started with the premise of we should get rid of that. You should be able to accept payment credentials and make payments right on your website, even if you're a small merchant that doesn't have a PCI compliance team. This same story of moving from non-integrated to integrated to embedded has happened in other fintech products as well. So when I traveled here, I booked my ticket on Delta, and buying travel insurance was one checkbox embedded in their checkout flow. Whereas 20 years ago, I would have had to go find an insurance agent to sell it to me. 10 years ago, maybe they would have sent me an email with a partner. Now, it's one checkbox. And of course, the same story is happening with credit. If I wanted to make a large purchase I couldn't afford, 20 years ago, I could have gone to my bank and taken out some kind of loan. 10 years ago, maybe the site I was checking out on would have a partnership where I could go somewhere else to get credit. And nowadays, again, one checkbox, one button built in a checkout flow, an embedded product. And so embedded UIs make for great distribution for products that already exist. And that distribution advantage leads to winners and losers in entire product categories. This talk is about how to build better embedded UIs. Now that we've talked about what an embedded UI is and why they're worth building and important to your business, next up we'll talk about the steps you need to do to ship one. First, designing the product at its core. Second, designing the developer experience for how people will integrate it into their existing products. And third, the engineering work that goes into building it internally. Let's start with product design. People who lead product design in fintech companies, you may already be used to fintech product design being a very different thing than product design in the rest of the world. We need a different mindset because we have different stakeholders and more constraints. And we have to communicate because that's a lot of information to keep in our heads. So always, when we build a product, we have to think about collaboration, stakeholders, technical limitations, et cetera. But when we build embeddable UIs, we add a partner between us and the end consumer. And that partner adds a whole extra dimension of stakeholders and constraints to the problems we're already trying to solve. As an example, when we're designing a UI for customers, if we're building a first-party product, we can do whatever we like. Maybe our team likes A/B testing, or our team likes UX research, our team likes following their gut. But when we build embeddable products, we can't just build a UI that our team is happy with. We have to be able to convince our partners that this is also the right UI for them to show to their customers. And so if our partners come from a different style of product or design culture, we may have to make trade-offs between what we think is right and what we can convince our partners is right for them to show to their customers. This can be very painful, especially if you're a platform that has a lot of data or has very well-grounded opinions about what the consumer experience should be. Sometimes your partners will have contradictory, and let's just say sometimes wrong, opinions about what their customers want to see, but they are important stakeholders and we have to solve for that constraint. That same idea that we have to satisfy not just our internal stakeholders and our customers, but also the partners in between who are embedding this UI, happens at every other layer as well. We can't just make it fast and reliable with our engineering team. We have to design an API that makes it fast and reliable even when embedded in somebody else's systems that are designed a different way. And we don't just have to make it secure and compliant and legal to the happiness of our stakeholders. We also have to prove that to external partners that may have a very different compliance, security, or legal culture. All of this is to say there's more stakeholders and more constraints than a normal product design. And so the mindset that we have when we design products like this is very different from, I always like to imagine a good product manager at a consumer startup who has in front of them 20 perfectly viable options for what to build, and they have to decide which to do. And we have the move fast and break things mindset, which says just pick one and go try it out and see what happens. We have maybe a more experimentation-driven mindset where we pick one and then test it against others rigorously. But all of these mindsets are predicated on the idea that we have lots of good options and we have to pick. And in fintech, that's not usually true, right? In fintech, if I have 20 options in front of me, it's only because I know all of them are impossible. This one is illegal, this one is too slow, this one is too ugly. And what I'm trying to do is navigate the minefield, assembling pieces from different alternatives until I find even one plan that actually meets all the constraints and optimizes for what we're trying to build. Because of these extra stakeholders, these extra constraints, even more than normal, we have to think holistically, checking how our partner contracts affect the UI we put in the text we put in our UI, checking the API design we have against our internal platform team standards. All of these constraints across layers and either teams or concepts, depending on whether you're a big company or a small company, require us to make trade-offs up and down the stack. This is really hard to do, and in general is very difficult to do in your head. In any project like this, there will come a moment when things are so hard, the trade-offs that have been imposed on you are so strict that you feel like, what if we completely abandoned this design approach and did something else instead? When you get to that point, the challenge then is, wait, does this new approach just solve the problems I have today, or does it actually solve all the constraints that I was already trying to solve? One way to solve that problem, of course, is to write them down. I know a lot of developers and product people maybe don't like writing documents because you're used to a world of writing a spec that says, here's what we're going to build, a thing which is completely pointless and out of date from the moment that it exists. Instead, what we want to do is write down not what we are building, but the chain of logic, the assumptions, the knowledge we have, the constraints we've learned, and the trade-offs we've made among them that have pushed us to a certain design. By writing down those constraints and the why, we let ourselves do a couple of things. When we have a new alternative proposal, we can check them against the pre-existing constraints and quickly tell if this path is doable or not. We also buy ourselves a great opportunity, which is that when the underlying assumptions change, our partners let us do something new, our customers have a different need, we can go check how those constraints played out in our product design, and maybe now we have a much better design possibility. So now we've gone through the process of thinking about the design of the product, maybe we have that written document of the trade-offs, how we weigh them, what we're going to try to build. But what's next is that although we know what we want to build for our customers and our partners, the biggest part of what will make it successful is the developer experience that they have when trying to integrate it and get it live. And by developer experience, I don't just mean the code that they write, although that's one part of it, but also whether they can hold it in their heads, whether they can estimate how much work it is to actually integrate this, whether they can tell how many cases they need to check. So what is it like to really be your partner and have to integrate your thing? The hardest part of setting a developer experience for embedded UI is control flow. Control flow means who's in charge, who gets to decide what happens next, and who's just waiting on hold for something to happen. To check our understanding of control flow, here are two mock-ups of embeddable payment widgets. These are very different widgets, and two very different sets of customers will like each one. Can you tell the difference between them? I got nothing. This is a little bit of a trick. The trick here is that in one case, on the case on the left, the component includes only collecting the payment fields, and the button is left to the surrounding page to implement. Whereas in the option on the right, the button is inside the component. The fintech platform actually handles what happens when you click the button. Even though the pixels presented to the user experience are exactly the same, these two components offer very different developer experiences and lead to two very different futures for this product. Neither one right or wrong, just trade-offs. When we think about the control flow for an embedded UI, I highly recommend using this shape, the four-square diagram. If you're used to a sequence flow diagram, this is a variation of that specifically for embedded UI. In this diagram, on the right, we have our fintech platform, and on the left, we have our partner, their tech systems. On the top, we have back-end systems. On the bottom, we have front-end systems. The reason to shape it this way, rather than as a sequence diagram, is because it makes it very easy to tell what kinds of communication are happening. Horizontal lines are API calls, webhooks, events going between our partner and our fintech platform. Vertical lines are front-end to back-end communication happening within one system that the other party doesn't need to worry about. And diagonal lines are more or less not a good idea, should not appear. It's probably a mistake if we have diagonal lines in our control flow. Let's look at an example of using this diagram to explain these two different control flows. In this option, where the button is outside the component, the integration starts by our partner's page rendering the component from our SDK. At this point, our component just knows, hey, I'm collecting a card. That's all I know. Next up, when the user hits the pay button, it's handled by the partner themselves. And so they can run whatever code, whatever API calls, calculations, control flow they want. In this case, their front end will hit their back end saying, hey, go make a payment with the API. And their back end will go call the API and describe the payment they want to make and pass the identifier for it all the way back to their front end. Their front end will then call our SDK saying, hey, I want to make this payment that I just created on the back end using the data in these fields in your component. Our component will then talk to our API to actually send the card data and take the payment. It'll send a webhook to our partner's server to tell them that the payment really happened. It'll send the data back to our SDK, and our SDK will emit an event saying, yep, it worked, it happened. You can show the next step in your UI. So this is flow one, where the button's outside. And you notice that in this case, our partner has a lot of control over the control flow. They get to do what they want at each step. Now let's look at flow two in this same four-square diagram. In this world, the button is inside our component, which means that when the user clicks it, our fintech platform needs to know what to do right away. And for that to happen, this integration starts by our partner server describing the proposed transaction to our API, threading that information back down to their front-end page, and now they render our component and give us some information about the desired transaction, which is probably just an identifier. Our component can fetch the information of the transaction securely from the API server. And when the customer hits pay, that pay button is inside our component, so our component hits our backends to tell us to make the payment, and the rest proceeds the same. We send a webhook, and we send an event back out to our partner. What you'll notice in this case is that the partner had to do more work up front and was not able to run any dynamic logic before the payment happened when the customer pressed the button in the UI. Now, is one of these better or worse? Should you learn something from this? Other than working the examples in the four-square diagram, the reason to show this trade-off is because it's a trade-off between the flexibility of what your partners can do versus the leverage of what your fintech platform can do. So let's illustrate that. In the option on the left, the component doesn't know what's happening in the transaction in advance. So all it can do is what the platform tells it, take a card. And the option on the right, because the transaction has already been described to our API before the component is rendered, the component has more information and more leverage to do things like picking a different payment method or currency, doing something to make the transaction dynamic. This trade-off is very real, and you'll find front-end UIs that offer one or the other, or sometimes even both. Stripe Elements now offers both of these approaches, one that's more flexible, one that has more leverage to do things for you. All right, so we've done the four-square diagram. We know what we want the control flow to be and how our partners are going to use this. Now let's actually design the API. The core thing to making a good embeddable UI API is to make it easy and universal. It needs to be lowest common denominator. Everyone in the world can use this in their app. The traditional way to do this, and an unfortunate one, is to ask your partners to directly embed an iframe with a URL pointed at you. There are some reasons why you still might do this, but in general, I wouldn't recommend it. You'll notice a couple things. If we want to pass in data, we have to stringify it into query params. If we want to send it messages, we have to use the raw browser post message API, which is unfortunate. It's hard to give it good names or types or linting or validation. And the post message API between the top level frame and the iframe is one-way communication only. So if we need to ask the iframe a question, our partner is going to have to send in a message and then add an event handler that listens to every message that comes back until it finds the one that is the reply to the message it sent. This is really unpleasant to work with. I wouldn't recommend it. Instead, what we want to do is wrap our iframes that are our implementation of the security boundary with a nicer developer abstraction that makes it easier to attach types by providing real properties and attributes or real method calls with named parameters. And we want to take that one-way only communication that postmessage provides and wrap it so we get method calls that return a promise that then results in the response coming back from the iframe. This is a big win for developer experience, which means developers can estimate it and write the code and test it and get it out faster, which is your distribution opportunity to get those partner integrations out faster. A final reminder here is that while your team may have very strong, and let's say for the sake of argument, correct opinions about things like which bundler to use, which type system to use, which framework to use, it's important to remember that your partners do not share those same views. And so if you're releasing a library that is a React library, a Vue library, or if your core SDK integration only works in TypeScript, that's a mistake. All those things are wonderful. Write a nice React wrapper for your low-level API. Write some TypeScript type definitions for your nice API. But make them separate from the actual framework or type system that you use internally. In fact, even if you build in React or TypeScript and you want to ship React and TypeScript to your users, they should be separate things. And have an abstraction barrier in between that is the minimal API. An important part of the API is deciding how your users can style, that is, customize the UI of your embedded component. I tried really hard to prep a good slide on this and have really good advice that would solve this for you, and I apologize, I couldn't. I think the real lesson, the high-level lesson I would give you from doing this a couple times is never work forwards from an implementation you already have. Don't build a component and then go, I guess we could make the font size a variable and we can make the border color a variable. What you'll end up with then are components that can be customized in a couple superficial ways, but if you try and do anything really interesting, it just won't consistently work. Instead, what you need to do is work backwards from your goal. Find your target users, maybe some aspirational users, Find the ones with the most interesting sense of design, and interesting could be good or bad, but just interesting. Design what you'd want your embedded component to look like in that context, and then work backwards to which style options you need to offer to build that. If you're retrofitting style options onto an existing component similarly, start with a target of things you want to be able to do, rather than just adding new style options. Okay, so we have a control flow, we have a proposal for an API, we maybe have a proposal for a style API. It's time to bring all these things together and ask, is this actually a good developer experience? How would we know? The way to do that is to write draft documentation even before you seriously start building your product. A draft integration guide should be roughly the docs you would ship to a beta user, somebody who's roughly familiar with what this feature does, but is not set up for it today. Your draft docs should include the exact API calls they should make, maybe with a couple little replacement tokens if there's something dynamic, but it should include the exact options that they would send to do a complete, even if minimal, implementation. And complete but minimal means it might not use every feature, but it should do all the error handling that it needs to do to be a realistic example in production. By listing all of these requirements, you can now, listing all of the steps, you can now tell, does your API and developer experience, is it cohesive? Is it well motivated? Is the naming right? And once you have those draft docs, you can do the first of what will hopefully be many reviews of your developer experience. There was a great talk about friction logs at last year's FinTech DevCon. I highly recommend watching this talk, which has good advice for checking your developer experience and checking your documentation. The basic idea of friction logging is you delete all the information that you have only because you work at this company, you turn off all your access to internal systems, and you pretend you're a real customer. And what can you do to start an integration with just the publicly available information? And you basically live blog that experience. You know, I was on this docs page and I got this far and then I didn't understand what this meant. I tried to find another docs page about this and there wasn't one. You just give the blow-by-blow of your experience. Now, Mike's talk last year is about friction logging big projects that are already in production, but you can do the same thing at a much smaller scale, even for a draft doc of a product that you're proposing. Finally, one extra piece of advice, if you're doing a friction log or asking somebody else to do one, always do at least one really weird thing. And by weird, I just mean outside the normal of what your company would check or what internally they would expect. Pick a different human language, a different programming language, a different browser, a different vertical than you normally think about, just so that the friction logging experience is broadening your experience of what it's like to use your product. All right, so now we have a proposed product description with our trade-offs and all of the complexity there. We know what we want our API and developer experience to look like. Now we gotta build the thing. Let's talk about the fun of engineering with iframes. I was once called by a friend who was in a difficult spot. They were on a team that was building an iframe-based UI, and they'd been developing and testing it internally. Stakeholders were really happy with it. And they had that morning had their first sales call with a prospect. And they were so proud, we have good docs, we're ready to implement. And they gave the person the docs, they were on the live call, they put in the right code, and the whole page was blank. The whole page was blank. And they thought, maybe the users typoed something, so they live debugged it with them. No, the iframe's on the page, the API calls are right, the whole thing is blank. This is a sad story about developing and testing in unrealistic ways. There are a lot of browser limitations about iframes, especially cross-origin iframes. If you think to yourself, I will build this web page and then I will stick it inside an iframe later, you're going to be very sad and end up with a blank page that doesn't do anything when it's iframed. Let's talk about some of the iframe limits, things that you might think will work, but don't. Let's talk about focus and blur. If we're navigating through a form, most people would expect to be able to type tab, use some assistive technology, so that if they're typing the name and now they hit tab, go to the next field, we'd really like focus to go into that card number input, right? That's what should happen. But that field is inside an iframe, and by default, the browser is not gonna move focus from the top level page to the iframe. And so if we want this to work, we're gonna have to write some DOM hacks and some JavaScript to get focus to move correctly between the top level page and our embedded inputs. And the same problem will happen on the other side. When focus is in our zip component and we're done and we press tab, that's going to tab back to the top of the iframe holding the zip component. It's not going to tab to the Buy Now button. Fixing this is possible and difficult and browser specific and browser version specific. You can go look at people who run big embedded component UIs and look at their DOM hacks. If you have a whole team who can maintain those and test them, it's an awesome user experience improvement. If you don't, it's maybe better not to touch it and just let people do it themselves. Similar stories happen for autocomplete. If these are separate iframes for each of these card inputs, if they were all on the same page and we auto-completed the card number, the browser would helpfully auto-complete the other fields as well. But because they're in separate iframes and separate documents, if the user uses the Safari autocomplete picker for the card number, the CVV and the zip are not going to get filled in because they're on another page. Again, you can hack around this with some fun DOM and JavaScript manipulation in order to collect all the information in one frame with invisible inputs, and then thread the information through to the right iframes and fill it in. Again, the same warnings as was focus and blur. This behavior is browser and version specific. If you don't want to get into fighting that fight, maybe you just accept that people have to autofill a couple times. A final limitation is user activation controls. So many browser APIs are only allowed when they're in proximity to a user action. So for example, your browser has an API you can call to make a phone vibrate, like to use that little thing inside the phone. The browser doesn't want that to just randomly happen when a web page is open that you're not doing anything with. So it actually gates that feature, along with many other things, like opening new windows and tabs, certain kinds of focus and blur things, to only be allowable if it's inside of the context of an event handler for something like the user pressing on a button on the screen. A challenge with this is that some of those user activation limitations will work across frame boundaries. So imagine if the customer is hitting a button inside an iframe, and we want to use one of those user activation gated APIs on the outside page. Some browsers, sometimes that will work. Other browsers, other times, that will not work. I give these as 3 examples, it's certainly not an exhaustive list, as justifications for why you should, from the very beginning, be developing and testing in a realistic environment. And what I mean by a realistic environment is put your embedded components inside a sample integration that a partner might write, and then host your iframes and that page at different origins and on HTTPS. Maybe you don't believe me now, I promise this is worth doing from day one. Browsers will treat iframes and outer pages differently if they're on different origins versus the same origin. They will treat them differently depending on whether they're local host or some other local network versus real internet, and especially whether it's HTTPS or not. So there are ways to automate this using tools like ngrok to just spin you up some proxy servers with real valid SSL certs. But seriously, do this day one, or you will, like my friend, end up in a situation where you have an iframe that works really beautifully by itself and then shows completely blank when embedded in another page on another origin. Next up, let's talk about communication with iframes. And this applies both to communication between the top-level page and the iframe and between different iframes if you run multiple. We already talked in the developer experience section about how the post-message API is really unpleasant to use for your users. Guess what? That also makes it really unpleasant to use for your developers. Again, a sort of day one task if you're building with iframes would be write a helper so that you have only one place in code that sends post messages and that directly receives the browser message event. And then wrap that with tooling that does all the other things you want so that the rest of your code just thinks in terms of methods and responses and doesn't have to think about the exact details of the iframe communication. Some examples of things you'll want to put in those helpers are translating one-way request flows into a request and response flow where the method call gets a promise for the response from the iframe. Possibly providing types. If you use a type system or a documentation-based system, static analysis-based system, you want to specify what are the valid shapes of messages and what are the valid shapes of a response to that message. You'll want to do security checks all in one place. Again, when you communicate between frames, you'll want to check that if you're receiving a message, you're receiving it from someone who you expect to and you want to listen to. And if you're sending a message, you want to send it to the expected other party, which may be yourself or your partner. And so you want to do those security checks all in one place. Finally, you may want to add things like debug logging. Frankly, the worst part about working with iframes is when you have a chain of post-message communications and then something breaks before the end, and you don't know, like, at which layer did this thing break? You want to add debug logging, again, to that one place that you send and receive messages so that you can turn it on in development and go, yeah, okay, here's all the messages. This is the one that's the wrong shape. Finally, let's talk about iframe security. Iframes are a useful security primitive that provide us some protection from the surrounding page. That said, you will sometimes find people who think because they're running in an iframe, that's enough. The sort of, security, I'm done. I'm in an iframe. And that is certainly not the case. There are many things that we can still leak, lose secure information, do something completely wrong, even if our code is running inside an iframe. The first one, of course, is checking the sources and destinations of the messages we send. It's very easy to be running in an iframe boundary and then just send the wrong thing to the wrong other frame, and now you have a PCI incident for your partners. A second thing to think about is parsing the data that you get from your users when it crosses the frame boundary. So if you accept any strings from the outside page, boy, howdy, think really carefully about what you do with them. In general, it is still possible to have an XSS attack inside of an iframe, right? If you take a string and the string has some escaped JavaScript in it, absolutely, your frame will run that JavaScript. The way to run defense in depth in these kind of attacks is to use the content security policy browser API. Content security policy lets a page declare what it is willing for its contents to do. Where can they load fonts and JavaScript and images from? Which sets of JavaScript on the page are allowed to actually execute? And where can we make network calls to? This is important if you accidentally have an XSS attack, but it tries to connect to some weird origin that's not in your content security policy. The browser will block it for you, which is great. The final thing to think about is that there are always, always interesting side effects that you would not expect that can still be security vulnerabilities. Let's talk about a really fun one that I don't know has ever been used in production, but it's such a wonderful attack, I think everybody should know about it. We'll imagine that in our styling API, we let our partners pass us in custom web fonts. Maybe they use CSS3 web fonts on their page, and they want the text in our inputs to match. So we let them send us CSS3 font specs. And in the general case, that's probably safe. Fortunately, the spec for CSS3 web fonts lets you define different files for different subsets of the Unicode space. So if you have a font that's defined for millions of characters, but your web page only uses Latin 1, you can only download the file with Latin 1. And then if your web page actually needs Klingon, then you can download the separate file that has Klingon. Unfortunately, an attacker could use this to specify different font files for individual Unicode code points. So in this attack, they've given us one file for us to load the font for the number 0, and a different file for the number 1, a different file for the number 2. You can see where this is going. As the user types out their card number, social security number, it's vaguely possible, I have to figure out if the timing is right, that they could use the network logs of this third party, whoever's hosting the font, in order to sniff out which characters were typed in. This is a fun attack. I actually don't know if it's very useful in production. You will find that people who provide embedded UIs that have thought about this carefully will tend to do something like render all the characters from 0 to 9 somewhere invisible in their iframe to make sure that they've just requested them all in a chunk and you can't sort of smell out which ones were actually typed in by the customer. All right, so we have a product, we have an API plan, we know how to get started on development. This talk has been sort of the 101 level of getting started working with iframes. But what I'd really like to do is have a conversation about what is next for people who already build, design, and operate iframe-based systems in production. And the goal of starting that conversation is to raise our ambitions as an industry. Because in the last 5-ish years, since all the iframe-based payment elements started coming out, things have slightly started to stagnate. I think that there's a lot more we could do to make these better in terms of industry standards. A couple ideas. Over the last few years, API companies have gotten better at providing a developer experience that guides people through API integrations. You know, a dashboard that lets them see you made this API call and it was what we expected, and then you've never made an API call like this, and that means we think you're not done integrating yet. I'd love to see that same kind of guidance and that sort of stateful memory of what have you done, what have you tested, are you ready to go to production yet? For front-end integrations as well. Can our front-end components send the right kind of anonymized telemetry back from people's test mode or developer experiences that we can know, hey, you've never added an error event handler. Your integration can't possibly be right. Please don't go to production. There's one idea. A second idea, styling APIs are still bad and hard. And even more than APIs being bad and hard, customers picking what style options they want to use is very hard. A lot of people who are integrating your product don't want to send you a JavaScript description of how to style these fields, because they already use Tailwind or some other design system, right? They have a thing like, I just want this button. I want your button to look like this button. Could we design some generative AI thing that you just pointed at a web page and go, I don't know, give me the style options for that button, please? This feels like it's doable, right? We should be able to do that. There are also new browser APIs that we could use. As people who build things with iframes, payments people who build things with iframes, we're pretty big on compliance and user data security and things like that. But the APIs and technical capabilities we use for iframes and invisible iframes and switching focus into iframes look to browsers as if we were malware vendors or like evil ad tech privacy violating people, because those are the other people who use iframes, but for more malicious things. It would be great if we could do things like the W3's Web Payment Working Group's payment handler spec, or other ways so that embeddable UIs that want to be responsible can be responsible in ways that users can check, browsers can verify, standards bodies can ratify, and that we don't have to get treated sort of the same as the invisible iframe privacy squandering people. There's some interesting work on this, and I'd love to talk about it, but not now. We're out of time. So I would love to hear from anybody here at the conference who does work with, design, build things with iframes in production. I'm hoping to get together a little sort of interest group, maybe here and then probably online at some cadence afterwards, to share industry knowledge and to sort of to advocate for the things that all of us could use, but many of us are sort of sitting lonely as the only iframe people in our respective companies. So please come find me. I'm not hard to find. I'm the tall guy with purple hair, so stop me in the hallway. After the conference, please send me an email, find me on LinkedIn. On my personal site, I will have up all the slides, a bunch of links, a bunch of extra material that I had to cut for time, as well as information on sort of joining that mailing list group to talk about iframe things. Finally, and maybe most importantly, a tremendous thank you. I'm thankful for this group of people being here together. This is more people than I've ever had in one place who are willing to listen and talk about iframes, so thank you. Second, I'd like to thank a number of specific people who sort of inducted me into the world of iframe magic. So thank you to Jenin, Michelle, Alex, David, Tyler, you know who you are. Thank you to my current employer, Rainforest, who sponsored me being here. I'm here, our CEO is here. We are happy to talk sales. We are very happy to talk recruiting. And then I'm very happy to talk iframes. Don't bother him about iframes. He'll give me shit about that. Thank you to the organizers of FinTech DevCon and the sponsors. I have been asked to tell you to rate me on an app. I have no further details. Thank you very much.